Imagine a wanderer from the depths of the galaxy hurtling through our solar system, a silent messenger carrying secrets from distant stars. This isn't science fiction, it's the reality unfolding right now with the arrival of 3I/ATLAS, the third interstellar object ever detected by humanity. As a geophysicist passionate about the intersections of space, electromagnetism, and even consciousness, I'm thrilled to dive deep into this extraordinary event. Discovered just last month on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, ATLAS Network, this comet is already captivating astronomers, scientists, and dreamers alike. But why should you keep reading? Because as we unpack its bizarre orbit, potential electromagnetic ripples, and even speculative ties to cosmic consciousness, you'll discover how this fleeting visitor could reshape our understanding of the universe, and perhaps even influence our world in unexpected ways. Stick with me through this journey, and by the end, you'll see why. 3I/ATLAS isn't just a rock in space, it's a catalyst for wonder that demands we watch its passage closely. In the coming sections, we'll explore everything from its discovery and orbital quirks to historical parallels with past interstellar intruders like Oumuamua and Borisov. We'll delve into the science of its plasma coma, ponder its possible effects on solar activity during this solar maximum, and even touch on thought-provoking theories about intelligence beyond our solar system. Updated with the latest data as of August 21st, 2025, from sources like NASA and the Hubble Space Telescope, this exploration is grounded in facts while embracing the mysteries that make space so endlessly fascinating. Whether you're a seasoned stargazer or just curious about the cosmos, prepare to be engaged, because the story of 3I/ATLAS is one that builds layer by layer, revealing profound implications that could echo long after it vanishes into the stars. The story of 3I/ATLAS begins with a vigilant network of telescopes scanning the night sky for potential threats and wonders. On July 1st, 2025, the Atlas Survey Telescope in Rio Hurtado, Chile, first spotted this enigmatic object, initially designated as a 11PL3Z. Pre-discovery images trace back to June 14, 2025, captured by multiple ATLAS sites and the ZWICKY transient facility at Palomar Observatory. What made this detection stand out? Its hyperbolic trajectory screamed interstellar origin, a path unbound by our sun's gravity, confirming it as the third such visitor after Oumuamua in 2017 and Borisov in 2019. The naming convention tells a tale of its own. 3I signifies the third interstellar object, while ATLAS honors the Discovery Network. Officially cataloged as C/2025 N1 ATLAS, it's classified as a comet due to its active icy nucleus and surrounding coma of gas and dust. But don't let the technical jargon deter you. This discovery is a testament to human ingenuity. In an era where technology allows us to peer deeper into the void, spotting something traveling at 61 kilometers per second, about 137,000 miles per hour, from beyond our solar system is nothing short of exhilarating. As observations poured in from Hubble on July 21st, 2025, the comet's features sharpened, a reddish tint suggestive of cosmic radiation exposure and a coma twice the diameter of Earth, hinting at volatile ices sublimating under solar heat. What draws us in further is the timing. Detected during solar cycle 25's maximum, a period of heightened solar activity, this comet's arrival feels almost serendipitous. Astronomers worldwide are mobilizing to study it, with ground-based telescopes tracking its path until it dips too close to the sun in late September 2025, only to re-emerge in December. The buzz is palpable. Could this be a pristine sample of material from another star system? As we continue, you'll see how its low-inclination orbit sets it apart, promising prolonged interactions that could unveil secrets hidden in previous visitors' brief flybys. Keep reading to uncover the orbital drama that makes 3I/ATLAS a once-in-a-lifetime spectacle. One of the most intriguing aspects of 3I/ATLAS is its orbital path, which defies the randomness we'd expect from a galactic drifter. Unlike Oumuamua and Borisov, which zipped through at high inclinations, cutting across the solar system's plane like hurried tourists, 3I/ATLAS glides nearly along the ecliptic, the flat plane where our planets orbit the Sun. With an inclination of just 175.11 degrees, retrograde, effectively 5 degrees from the ecliptic, it's almost as if this comet was aimed with precision. This alignment means it'll linger in the Sun's electromagnetic embrace far longer, interacting with the heliospheric current sheet, a wavy skirt-like structure of solar wind, for an extended period. Visualize this. Starting from about 4.5 astronomical units out beyond Jupiter's orbit when discovered, 3I/Atlas is barreling inward on a hyperbolic orbit with an eccentricity of 6.139, the highest among known interstellar objects. Its perihelion, the closest point to the Sun, occurs on October 29, 2025, at 1.356 astronomical units, about 126 million miles, just inside Mars's orbit. At that moment, it'll accelerate to a blistering 68.3 kilometers per second, fueled by the Sun's gravity. But here's the hook. This retrograde motion, opposite to planetary orbits, adds a layer of intrigue, potentially stirring unique gravitational and electromagnetic dynamics. As of August 21st, 2025, animations from tools like the Sky Live show 3I/ATLAS approaching from Sagittarius, skimming the ecliptic with remarkable accuracy. This isn't just bizarre, it's statistically improbable considering the Sun's motion through space. Our solar system hurtles toward the constellation Hercules at 20 kilometers per second, yet 3I/ATLAS matches this velocity vector closely enough to hug the plane. Coincidence? Or a clue to its origins in a distant star-forming region, ejected eons ago? The comet's speed and path provide conclusive proof of its extrasolar birth. With a hyperbolic excess velocity of 58 kilometers per second, it couldn't have originated from the Oort cloud, our hypothetical distant reservoir of comets. Instead, picture it as a rogue, flung from a young stellar system, wandering the Milky Way for millions of years before intersecting ours. Its reddish hue, likely from cosmic ray bombardment, and water-rich composition, detected via spectroscopy as ice, vapor, and hydroxide, paint a picture of an ancient traveler, carrying organic compounds that could hint at the building blocks of life elsewhere. But the real engagement comes from what this orbit implies. As it sweeps through, it'll cross paths with inner solar system elements, potentially influencing solar wind patterns and planetary alignments. Around October the 22nd to 23rd, 2025, a superior conjunction aligns Earth, Sun, and 3I/ATLAS with Mercury, Venus, and Mars, forming near-perfect geometries, squares and lines that historically correlate with solar flare spikes. Intrigued? The next section reveals its close planetary encounters, building the suspense for how this could ripple through our cosmic neighborhood. As 3I/ATLAS hurtles inward, its path brings it tantalizingly close to two key worlds, offering rare opportunities for study and speculation. First up, Mars. On October 3rd, 2025, the comet will skim just 0.1936 astronomical units, about 18 million miles, from the red planet, a cosmic near-miss that could allow missions like NASA's MAVEN orbiter to gather data on its coma and tail. Jupiter's massive gravity might slightly perturb the comet's path, but more excitingly, the Juno spacecraft could probe it, examining dust, gas, and potential ion tails. These flybys aren't just scientific gold mines. They underscore the comet's prolonged stay in our system, unlike the quick exits of predecessors. Other brushes include Venus on November 3rd, 2025, 0.649 astronomical units, and Earth on December 19, 2025, 1.797, a U or 167 million miles, far enough to pose no threat but close for telescope views. To appreciate 3I/ATLAS's uniqueness, let's rewind to its siblings. Oumuamua 1I/2017 U1, discovered in 2017, was a cigar-shaped asteroid-like object, tumbling through at a 123-degree inclination, perihelion at 0.25 astronomical units on September 9, 2017. It briefly intersected the heliospheric current sheet, coinciding with unexpected X-class solar flares during solar cycle 24's decline, flares that were anomalies for that phase. Borisov 2I/2019 Q4, spotted in 2019, was more comet-like with a tail, inclined at 44 degrees, perihelion at 2 astronomical units. Both were fast but fleeting, interacting minimally with the solar wind's ballerina skirt. 3I/ATLAS stands apart. Its near-ecliptic retrograde orbit ensures extended exposure. Size-wise, its nucleus, 0.32 to 5.6 kilometers, is comparable to Borisov, 0.2 to 0.5 kilometers, but potentially more active, ejecting dust at rates similar to Jupiter family comets. These comparisons fuel excitement. If Oumuamua linked to flare spikes, what might 3I/ATLAS unleash during solar maximum? The next section explores potential solar activity boosts. As we delve deeper into the implications of 3I/ATLAS's journey, the potential for it to influence solar activity emerges as one of the most captivating possibilities. During its perihelion on October 29, 2025, at approximately 1.36 astronomical units from the Sun, this interstellar comet will be positioned to interact extensively with the solar wind and heliospheric current sheet due to its alignment with the ecliptic plane. Historical precedents, such as the passage of Oumuamua in 2017, suggest a correlation between interstellar objects and spikes in solar flares. Back then, during the descending phase of solar cycle 24, a period typically marked by waning activity, multiple X-class flares erupted, including some of the strongest of that cycle, precisely around Oumuamua's closest solar approach on September 9, 2017. This sets the stage for 3I/ATLAS to act as a catalyst. Its plasma-rich coma, ionized by solar radiation, could disrupt the heliospheric current sheet, which during maximum extends vertically but folds back, creating opportunities for prolonged electromagnetic coupling. Imagine the Sun as a dynamic engine, pumping out ionizing radiation that transforms the comet's gaseous envelope into a conductive plasma. As 3I/ATLAS slices through the inner solar system from October through November 2025, this interaction might amplify solar output, leading to enhanced flares, coronal mass ejections, CMES, and geomagnetic storms on Earth. The superior conjunction around October 22nd to 23rd, 2025, aligns Earth, Sun, and the comet, with additional planetary geometries involving Mercury, Venus, and Mars, potentially exacerbating these effects, much like how alignments have historically boosted activity. If Oumuamua's brief passage triggered anomalies, 3I/ATLAS's extended stay could prolong this influence, offering a natural experiment in solar physics. But the intrigue doesn't stop at flares. It extends to how this plasma dance might ripple through our entire system, affecting everything from satellite operations to auroral displays. Stay tuned as we explore the science behind its coma and why plasma is key to unlocking these mysteries. At the heart of 3I/ATLAS's potential influence lies its expansive coma, a glowing envelope of dust, gas, and plasma that Hubble observations from July 21, 2025, estimate to be about 26,400 kilometers in diameter, roughly twice Earth's size. This isn't just a passive cloud, it's a dynamic plasma structure, formed as solar ultraviolet and X-ray radiation ionizes sublimated ices from the comet's nucleus, which ranges from 320 meters to 5.6 kilometers across. Plasma, the fourth state of matter comprising 99.9% of the visible universe, endows this coma with electromagnetic properties that could interact with the sun's magnetic field and solar wind. In complex dusty plasmas like this, dust particles accumulate charges, forming double layers, crystalline structures, and regions of varying temperature that behave almost organically, adapting and maintaining coherence over time. This lifelike quality arises from the interplay of ions, electrons, and dust, creating a conductive medium that might couple with the heliospheric current sheet, potentially inducing currents or magnetic reconnections on the sun. Updated spectroscopy from the Nordic Optical Telescope confirms water vapor, hydroxide, and a reddish tint from cosmic ray exposure, indicating millions of years of interstellar travel. Venturing into more speculative territory, the arrival of 3I/ATLAS prompts intriguing questions about consciousness, plasma, and cosmic information transfer. Ideas grounded in theories like general resonance theory, which posits that consciousness emerges from vibration and resonance at various scales. If plasma is a medium for such processes, as some researchers suggest, then this comet's plasma coma could act as a carrier of interstellar codes, energies, and patterns accumulated during its galactic wanderings. While mainstream science views 3I/ATLAS as a natural icy body, public discourse, including discussions on platforms like X, formerly Twitter, buzzes with theories of it being an alien probe or artifact, fueled by its precise ecliptic alignment and high speed. Ruling out extraterrestrial technology doesn't negate the possibility of intelligent interaction via plasma dynamics, perhaps subtly influencing solar activity and, by extension, planetary consciousness fields. During solar maximum, elevated ionizing radiation from the sun enhances plasma states system-wide, potentially amplifying resonances. Supporting evidence includes spikes in solar flares during past interstellar passages, which correlate with geomagnetic effects on Earth that some studies link to altered states of consciousness. As 3I/ATLAS interacts with the sun, flares could broadcast these codes via solar wind to all planets, fostering integration over months or years. This perspective encourages us to view the comet not as a threat, but as a galactic gift, prompting personal reflection and scientific inquiry. But how rare is such a visitor? The following section examines the frequency of interstellar objects and what it means for our understanding of the cosmos.